Okay, alright guys, here's question 9 as promised. So the first one's a show that question. So we're using the fundamental trig identity, which is sine squared plus cos squared is equal to 1. And we know our final answer is, what's that? It's going to be 2 cos squared x plus 7 cos x plus 3 is equal to 0. Oh yeah, feel free to have a go at the question, like pause the video and have a go at the question first, because I realised the main thing that's wrong with it is the formatting wasn't coming out on Google Classroom. So yeah, so do that now. Right, so it's a show that question. So we just want to put the working in all the way down until we get to the answer, how many steps that's going to be, and we want to rearrange this fundamental trig identity. So we're starting off with sines and coses, we end up with just coses. So we want to get sine squared is equal to 1 minus cos squared, that's what we'll be using. So 2 to the sine squared, 1 minus cos squared, x is equal to 7 cos x plus 5, and that implies, expand that, 2 minus 2 cos squared x is equal to 7 cos x plus 5. And I think, yeah, it follows from that. So we're done. That's enough working. Okay, for the second part, again, if I write the question out, 2 sine squared 2 theta is equal to 7 cos 2 theta plus 5. We're going to need the domain as well. So minus pi less than theta and 2 pi. So again, like pause the video, have a go at it, and then yeah, then have a look. Okay, so it's the same as the first part of the question, right? So it's hence or otherwise show that. So I'm just going to replace this with the equivalent of here. So we've got 2 cos squared instead of x. We've got 2 theta plus 7 cos 2 theta plus 3 is equal to 0, and we want 2 theta instead of theta, so I'm just going to multiply that by 2, minus 2 pi, multiply that by 2, 4 pi. There you go. So we want all the solutions in between that and that, and it's cos. I'm just going to draw a little cos graph. Okay, between minus 2 pi and pi, so that's 1 period, 2 periods that way, that's 2 pi, that's 4 pi. Do the whole thing in radians, don't convert it to degrees and back again, just try and think in radians. Minus 2 pi there. Oh, slightly out of the camera. Oh, there you go, have a look at that. Okay, so yeah, so and we're looking, right, anyway, so we'll factorise that, won't we? So 2 cos squared 2 theta, cos 2 theta, oh, hang on, no squared there. Okay, everything's prime, so you should be able to do this by inspection. Plus 3 and plus 1, multiply that out, you should get the 7 cos 2x, yep, cos 2 theta even. So that's good. So we've got two solutions. We've got 2 cos 2 theta plus 1 equals 0, and from that you get cos 2 theta is equal to minus a half, and then you've got this one, which is cos 2 theta plus 3 equals 0, and from that you've got cos 2 theta is equal to minus 3. And then we go back to our sketch. We know the range is between 1 and minus 1 for a cos graph, hasn't been transformed in the y direction. So you can see from that ain't going to have any solutions. And this one's going to have how many solutions? Cos to it's minus a half, so minus a half is down there. We're going to have 1, 2, 3, 4, 5, 6 solutions in total. There they are. And then we're in radians, so make sure I calculate in radians. Set up, hang on, no. Shift setup, angle input 2 for radians. Right, we're in radians, little r up there in the corner. Oh, you can see that, little r up there. So shift cos with minus a half, and we get a principal value of 2/3 pi. So then 2 theta is equal to, and I'm going to put the principal value down here, 2/3 pi, because I know I'm going to get some more answers here before it, and just so they're in kind of ascending order. 2/3 pi, that's pi by 2 there, isn't it? So that looks like that one is our principal value that we've been given. Let's just move that down a little bit. So that is the principal value. And then it's cosine, so where's the symmetry work? the symmetry is in between 0 and 2 pi. So this one's going to be 2 pi minus 2/3 pi, which is 4 pi over 3. You can see also cos is an even function, which means it's a reflection in the y-axis. Even, another way of writing that is f of theta is equal to f of minus theta. So that's a reflection in the y-axis. So we know this one's going to be minus 2 over 3 pi. This one's going to be minus 4 over 3 pi. What about these two solutions here? So that's that one and that one. That one and that one done. To get these two, we'll add 2 pi to this one, add 2 pi to the principal value. So it's going to be 8 pi over 3. And then we'll add 2 pi to this one. That's going to be 10 pi over 3. There we go. 6 solutions done. The third part of the question is solve sine 2x plus 30. Now there's no squareds on this one, but we've got a mixture of sine and cos. So we're probably going to be using another identity. Oh god, run out of space for the domain. It's important. X less than 180. So we know that tan is equal to sine over cos. Or here tan 2x, say, is equal to sine 2x over cos 2x. So if we divide both sides by, okay, well anyway, you could have paused it at the beginning. Pause it at the beginning if you want to have a go at it. If we divide both sides by cos 2x plus 30, cos 2x plus 30, then that cancels and what we get is tan 2x plus 30 is equal to 1. 0 less than x is less than 180. We want 2x plus 30, so we want to change the domain again. So that's going to be 30, that's going to be 360 plus 30 is 390. So then 2x plus 30 is equal to, right, let's have a look then. Want tan graph. Where's that? That's 90, isn't it? I can do it in degrees this time because we're in degrees. Period of 180. So that's going to be 270. And then we'll have another one coming down here, taken up to 360. Oh, okay. I guess that's 360 there, isn't it? And that's 450. So let's see. Equals 1. Okay, so then we got 2x plus 30. Oh no, by the way, I haven't finished this question off. Just notice that's 2 theta. We want theta. So we should divide everything through by 2. So you get minus 4 over 6 pi, minus 2 over 6 pi, 2 over 6 pi, blah, 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 4 pi over 6, which you can simplify. We'll let you do that. 8 pi over 6, that would be 4 pi over 3. And yeah, 5 pi over 3. Or 10 pi over 6, and then simplify those, okay, to get what's in the mark scheme. So similar to this one. All right, principal value shift tan of 1 is 45 degrees. I can see from my sketch I don't need any negative ones, so I'm not going to bother putting any place in that. So 1's there, so we're going to have that value there, and maybe this one. We'll see if it's in the range, in the domain, sorry. So tan, what do we want to do? Add 180 to each of those. So add 180 to that as you get 225. Add 180, you get 405 degrees outside of the interval. Just get those two, then solve that for x. So take away 30 from each. This is where people sometimes make a mistake. What you might call a silly mistake. What I would call a lack of practice. Okay, so there you go, there are your solutions. All right, so there you go. Hopefully that's clearer, and enjoy.